In the previous video we did A, now we have to do B. So the function is equal to x plus 9 over x. So we can write that down as x plus 9 times x to the power of minus 1. Okay, so for the first part we have to take the derivative. So the derivative of this is equal to, so the derivative of x is 1, and the derivative of 9 times x minus 1 is 9 times, we move the exponent to the front, so minus 1, times we lower the exponent by 1, so minus 1 is x to the power of minus 2. So that's going to be equal to 1 minus 9 over x to the power of 2. Okay, then we have to find the position and nature of the stationary points and also draw the sign table. So we're going to do that together again. So I and I. Okay, to find the stationary point we equate the function to 0 again. So we have to equate this here. So the 1 minus 9 over x squared to 0. So when we move the 9 divided by x squared to the right hand side, that's going to become 9 over x squared. So when we move the x squared to the left hand side, we get like 1 times x squared, which is just x squared. And that must be equal to 9, or x must be equal to plus or minus 3. So we're going to have two stationary points in this case. And to find the y-coordinate of the stationary points, we have to fill that in the function. So x is equal to 3 and x is equal to minus 3. So f of 3. So when we fill that in here, that's going to be 3 plus 9 over 3, which is equal to 3 plus 9 over 3 is 3, so that is 6. And here, when we replace x by minus 3, then we get like minus 3 plus 9 over minus 3, and that's going to be minus 3, which is equal to minus 6. So the first stationary point has coordinates 3, 6, and the second one has coordinates minus 3, minus 6. Okay, so those are the coordinates of the stationary point. So let's make the sign table. So the derivative of the function is equal to 1 minus 9 over x squared. To create a sign table, you put like both terms on the same denominator. So we do the 1 times x squared divided by x squared, because x squared divided by x squared is just 1, minus 9 over x squared is equal to x squared minus 9 over x squared, or the derivative is equal to x squared minus 9 is x minus 3 times x plus 3 divided by x squared. Okay, so we have to create the sign table of this. So we have x minus 3 here, x plus 3 there, and x squared there. First we have the derivative of the function, and then we will have the function. Okay, so the critical points are 3, minus 3, and 0. We have minus 3 here, we have 0 here, and we have 3 here. So x minus 3 is 0 when x is equal to 3, and above the 3 then it's positive, because when we fill in, for example, x is equal to 5, 5 minus 3 is positive. When it's below 3, then it's negative, because for example 1 minus 3 is minus 2, which is negative. So here it's negative. And x plus 3 is 0 when x is equal to -3 and both it's positive and below it's negative. And x squared is 0 when x is equal to 0. And it doesn't matter on the left hand side or right hand side, it's always positive because you do to the power of 2. Here we do a negative number times a negative number which is positive, divided by a positive number is positive. Here we do a negative number times a 0, which is 0, divided by a positive number is still 0. Here a negative number times a positive number, which is negative, divided by a positive number is negative. Negative number times a positive number is negative, divided by 0 doesn't exist. So we write that down like this when it doesn't exist. Here a negative number times a positive number, which is a negative number, divided by a positive number stays negative. Here 0 times a positive number is 0, divided by a positive number is still 0. Positive number times a positive number divided by a positive number is positive. So when the derivative of the function is positive, then the function is increasing. When it's negative, it's decreasing. When it's negative, it's decreasing. When it's positive, it's increasing. So here it's increasing and here it's decreasing. So that means that we have here a maximum turning point. So maximum turning point. Here before the stationary point it's decreasing and then it's increasing, so that means that we have a minimum turning point. So I'm gonna write that down here. So we have a maximum turning point at the point with coordinates -3, and we already calculated the y coordinates, which is -6, and we have a minimum turning point at the point with coordinates 3 and 6. Okay. And now the last part. For the last part we have to sketch the graph. To do that we use GeoGebra again. Okay, we go to GeoGebra, and when we sketch the graph we see this. And we can see very clearly that the minimum turning point is at has coordinates 3, 6. We also call it extrema, by the way. And the maximum turning point has coordinates -3, -6. We just have to sketch this graph. When we sketch it, it will look like this. Okay, and we have here the minimum turning point, and here we have the maximum turning point. Okay, that's it.